Hey everybody, it's spring 2022 and this is a lecture on recursion. Recursion can be a pain in the butt, but once you get it, you get it. It's kind of, if you've ever seen the movie Inception, it's a lot like Inception, where you have a function going in itself and itself, like a dream within a dream within a dream. This is like doing a function within a function within a function, and it's the same function. So this is notes 4B, our logical operators and recursion. We just got done doing logical operators the other day. And right now I'm going to go over recursion. We're going to do this void countdown. And I have copied it over and pasted it into a computer. Not in a computer, into Virtual Studios. And I set up the include. I've did the using namespace. Notice I did the function prototype at the top up here and the functions down below. So let's just see what happens. It takes in an integer and it doesn't return anything. So let's just see what happens if we do like countdown 5. And we let it run. So it goes 5, 4, 3, 2, 1, blast off. And then it says after call 1, after call 2, after call 3, after call 4, and after call 5. So what's going on here? Let's take a look at this code right here. So when it starts, if n equals 0, and it did, it's gonna. So we're working with a lot of if and else. So if n equals 0, this is called our base case. The one that's the bottom tier. If n equals 0, we just see out. And then apparently the function stops because the else doesn't run and the countdown's done. So if n doesn't equal 0, it goes into the else thing and it does a see out or prints to the screen the number. And then it does countdown n minus 1. So what it's doing is that, like we had n equals 5, it sends down in 5 minus 1, does countdown 4. It runs countdown 4 and it pauses the program right here until countdown 4 runs. So I'll type that real quick here. Countdown 5 will go to here and run countdown 4. And pause until it's done. Okay, so an easier way to look at this is getting out some pen and paper. So I finally figured out how to get my Surface Pro to work well with my laptop. I've got remote sharing going on. So I've got my Surface Pro connected here. And I thought we'd just walk through it. So let me draw, I've got screen. Okay, so let's start. The way we want to do it is we want to start at the bottom, okay? Because this is in, when we run in the main, we're going to do in main. I'm starting at the bottom. We're going to do countdown 5. And what that's going to do is it's going to send it over into, it's going to start running it in memory. And the first thing it does, maybe I should make this, get rid of that line over there. Make it a little bit longer. Hopefully that works. So we have n equals 5. And it does a see out of that value. And then the other thing it said was do countdown 4. So if I make this like a little printout of what my screen is right here, this is my screen. So we did n equals 5. We put in countdown 5. It did 5 the screen right there. Okay, so now when it's calling on itself, it sends it to, it's called the heap. It's in memory. It's where the computer does all its work. And since this program has not stopped running, it pauses right here. So pause while this takes effect. And it goes up and it does countdown 3 or countdown 4. N equals 4. It does a C out of 4. So that goes on the screen. Then it runs countdown 3 and pauses here. So we put in a little pause right here. And this is going to keep happening. This goes up to n equals 3. We have a C out of 3. That prints it to screen. We go countdown 2. We're ticking down. We have a pause. And it runs countdown 2. I made those boxes on the bottom too big. C out 2. It run. Oh. It runs countdown 1. With a pause here. And countdown 1 runs. So we have a C out of 1 here. Then countdown 0 runs and we have a pause. So they just keep stacking on each other. This is called the stack. The stack. Ooh. So we're going to keep stacking on it. We're not done stacking. We got to do countdown 0. So it goes up and runs countdown 0. So n equals 0. And n equals 0 was the base case. What happened in the base case? Let's go take a look. So in the base case, it did C out of blast off. So we got C out of blast off, and then the program ends. That function state ends. All of these are called function states or function instances. And now that we've done n equals 0, if we look at the program, countdown with 0 ends here. So that means this comes off the top. We call that popping off the stack or pop off the stack. Okay, and there's a reason for it. When we start doing other commands, pop is the command that we use for stacks. Okay, so n equals 0 is done, and now it goes back. This was n equals 0 was in here. Oops. N equals 0 was right here. This is where we paused. So the pause goes away, and we do the next line in countdown 1. So what was the next line in countdown 1? Countdown 1 is the next line after is this line 22, C out after call N. Well, countdown 1, N was 1, so after call 1. So that's what happens here. So now we see the after call 1. We have our C out over here. C out after. And then that program ends. That function for countdown 1 ends. That function state ends. And so we got to pop countdown 1 off the stack. And that returns us back down to where we left off last time, which was at the pause in countdown 2. So the pause in countdown 2 was to do a C out of after call 2. So after call 2 prints the screen. And I'm going to just pop this off the stack because I think I'm not going to have enough room to write on my text there. Pop off the stack. I picture it like a bottle cap coming off, but I don't know if that's really all that applicable. Then, just like in countdown 1, this was the end of the function call. So the function call to countdown 2 ends. And we return to countdown 3 right where we left off, right at the pause. So countdown 3, it had do a C out of after call N, and after call N for this one is C out after call 3. So after call 3 goes to screen. And hopefully this process is getting kind of clear. Drop. After call 3 was done, the function call to countdown 3 is done. So we pop it off the stack and we return to the previous function where we left off, because these are all like, it's all like it's embedded. And that's another way to look at it. When I'm done doing the picture, I'll show it typed out kind of thing. So here we return to countdown 4. Countdown 4 paused there. The next line was C out after call 4. So that's what we do. We print after call 4 to the screen. And then this function call to countdown 4 is terminated. We're done with it. So we pop it off the stack. And we return to the previous function state, right where we paused. Here, the only thing left in this function was C out after call 5. I guess it didn't need parentheses there. And it says after call 5 on the screen. We've completed that one. The final function state ends. And we return to the main, and the memory all gets deallocated at this point. Okay, so that's kind of what happens if we draw it out. Let's take a look at it like if we typed what's going on the screen. So what's going on is we do countdown 5. I'm going to just type it up here in the main. And I'm going to use a block. We'll type in a block. So it's just comments. So countdown 5 runs. And the if gets passed. So countdown 5. If passed, else triggers. So what happens there? We have a C out of 5. C out n, so C out 5. Then it does countdown 4. I'm going to use tabs to show like an embedded nature. C out 5 is inside countdown 4. We've got countdown 4 now. So countdown 4 runs. The if statement is passed. It does not meet the criteria. The else triggers. And the else is a C out of 4 and runs countdown 3. And I'm going to copy and paste this because this happens a few times. So the countdown 3, the if statement is clearly n does not equal 0. So we got to skip it. We go to else. And now count C out the 3 is inside countdown 3. Maybe I should be doing like brackets. Let's do the brackets. So we have a C out of 3. We run countdown 2. And here the if statement gets passed. Let's copy that whole thing like that. So the if statement gets passed, the else triggers. We do a C out of 2. Then we do a countdown of 1. The 1 function runs and it goes in, it's doing its own function thing. Again, the if statement's passed. We have a C out of 1. And then we have countdown 0. Countdown 0, the if statement triggers. So there we have a C out of blast off. I believe. Let's just bring that back up so we can see it. Yeah, we have C out blast off. And then countdown ends. Countdown 0 ends. Which means we have a curly brace, the end of it, and we return back to countdown 1 where we left off. Countdown 1 where we left off was this line 35, C out after call end. So right here, we do the C out after call N. But N is 1. And now countdown 1 ends. So we're going to put its N curly brace here. Oop. And I should be doing that at the same level as the one before it. So let's do countdown 1 ends there. The rest of countdown 2 triggers, which is the see out after call. So I'm going to start copying this line. See out after call 2 runs, and then countdown 2 ends. And so this is where see out countdown 2 lined up right here. So I need to put the curly brace there. And maybe if I show these with a little bit of it, like I got a lot going on. So let's show it kind of like indented a little bit better. So this one ends, and we're back down to countdown 3. The last function or last line to run in countdown 3 was the see out after call. So it after calls 3. Then countdown 3 ends. So we got a nice little curly brace here. I tabbed that. There we go. That looks better. So these are like nested functions. Recursion is like nested functions. And that's what I meant by the movie Inception. The dreams are within the dreams. This is a function call within another function call. So countdown 5 goes, and then countdown 5 can't end until countdown 4 ends. That can't end until countdown 3 ends, and it goes all the way down to the base case. So countdown 0 was our base case. That ended the if part. The rest of the else's got to trigger. So we start doing the after calls working outwards. This is countdown 0. This, and now countdown 0 is done. Then we finish off countdown 1 with the see out after call 1. That one gets done. And we go back to countdown 2. We finish at countdown 2. Now this is deleting it right now. I'm popping it off the stack. So we see out after call 2, countdown 2 finishes. We pop it off the stack, return to the previous countdown. I did a see out of 3, countdown 3 ends. We pop it off the stack. And we continue running. That we have a see out of after call 4. This is a better way of doing it than I should have deleted it the whole way. We have the see out of after call 4. This function ends. And then we pop it off the stack. And finally, countdown 5 has its final see out of after call 5. It ends. Countdown 5 is done. We pop it off the stack, and we are back in the main. So one way is looking at it like those nested functions like I did on the screen. And another way is doing this thing right here. Oh, wow. I don't know if I was on the screen the whole time. Why is it, no matter how much I zoom out on this, it's only showing so much on that screen? That's interesting. That sucks. So I'm going to pause it. Oh, this is what I get for having OneNote open on my computer as well. So my laptop, I'm going to close it there. Where I was looking at it for the computer was this remote desktop. So this was the other option we had. Okay. And that was doing the printout. And then notice it keeps going up one direction. The stack keeps building in the heap. And then it's kind of just collapses back down. As we finish each thing on top, we pop it off. Yeah, I know I had fun making jokes about popping off and stuff like that. It is a command when we start working with vectors on how to do some stuff. So, and working with stacks. So it's kind of helpful to use the word pop, or we're collapsing it, we're removing it, we're deleting it from the stack. Each time that memory gets deallocated because the function's done, and we finally get back to the main. That's it for recursion. I recommend that you give this one a try and try to do the same thing on your own. Maybe do factorial 3 or 4. Just as a reminder, the way factorials work. Factorial 4. Factorial is the 4 with the exclamation point. And exclamation point, well, in C++ means not, but in mathematics, the exclamation point means keep dropping down by an integer through multiplication until you get down to 1. So if you do factorial 4, you should end up getting 4 times 3 times 2 times 1 is 24 when you're done. If you do that, do factorial 4, you should get 24. I recommend doing this recursion stack in drawing out a heap like this. I really recommend drawing it out. It takes a little bit longer. And then if you've liked the nested thing that I was doing here, I'd give that a shot as well. That's it for now. I will see y'all later. Peace.